Today we're going to do some filling in some notes. This is so we don't waste time in class doing it and that you can have some familiarity with the information before we get to working with it. So first thing, what is an algebraic expression? An algebraic expression can have variables, numbers, addition, subtraction, multiplication, division, parentheses, square roots, exponents. You can have all these really cool things. It can even have letters, you have smiley faces. And we have some examples here. We have x minus 2 divided by 3 times the quantity x plus 2. Then we have negative 5b plus 7c minus d. And we have a square root of 5xy. Now, symbols are letters used to represent an unknown. Example, x, theta, beta, smiley face. I always like the smiley face. These are all called variables. They stand in place of a number that is not known. It still has to act like a number. It has to dance like a number. It just doesn't look like a number. It's sort of like if you went to prom and you put on that fancy dress, or you put that coat and tie on, you're still the same person. You still act like the same person. So you're not acting like a dog. You're not acting like a cat. You're still acting like yourself, and that's what a variable is. A variable is just a dressed-up number. All right, how many items are being added and subtracted? We call that terms. And the clue here is added or subtracted. When we have things that are being added, we have terms. That means this is something being added or subtracted. This is something being added or subtracted, and this is being added or subtracted. So how many terms are there in this example? 3. All right, now let's look at this one down here. How many terms are in this? Well, let's look. Where do we have things that are being added and subtracted? We have p, 2x, a squared, and b. So we have 4 terms. All right, now, same variable raised to the same power, okay, would be like terms. All right, and that means we're going to look at strictly the variable parts. Okay, this one over here, x squared y and x squared y. That means these are like terms. Negative 7y squared and 22y squared have the same variable parts. If I had given 4xy squared, these are not like terms. Very important, okay, because when we talk like terms, we're talking strictly about the variable part, not the number in front. Now, the number in front of a variable, ooh, it has a name too. It's called a coefficient. All right? Now, I'm only looking at the number in front of all the letters. Okay? This one is 1, 2, 3, so my coefficient is 1, 2, 3. The coefficient of this term, okay, is 9. And of course, we have this x, and you're going to go, oh, well, it doesn't have a coefficient. It must be 0. You'd be wrong, because it has what we call an understood coefficient, and that would be 1. Understood coefficient of 1, so the coefficient for this particular x is 1. Any other coefficient stands there, and we can see it. We have invisible ones when we have a variable standing all by itself. Now, the number up in the air next to a base, okay, this is also the number of times you are multiplying something by itself. This is called an exponent. Okay? Examples. The 3 is an exponent. Okay? The exponent in the x by itself, well, we have another understood 1 hanging out there. So I have an exponent of 1. And for negative 3, y to the 4th power, Our exponent is 4. Now, what is the exponent resting on or sitting on? It's the part that has been raised to a power, and we call that the base. Just like your butt is your base for where you sit down, an exponent has a base. It sits on a number or a letter. So the base for 2 to the third power, the base is the 2, right? The base for that understood 1 exponent would be x. And the base for negative 3y to the fourth power, the base is not the negative 3. The base is only the y, because that's what the exponent is sitting on. Now, a number that has no variable. It can be a positive number, it can be a negative number. And this is called the constant because it does not change. It is consistently always there, right? A variable is something that varies. It changes because you can plug other numbers in. A constant doesn't change. So in an equation, a number that has no variable is constant. Okay, an example, negative 42. Negative 42 is constant. What's the constant in 3x plus 5? Well, the only number that does not have a letter with it would be 5. Okay, now when we have this trinomial down here, 5x to the squared plus 3y to the fourth power minus 8, the constant there is negative 8. Okay, items that are being multiplied together. Pay attention to operations, guys. Remember, terms talked about addition, subtraction. Now we're talking about things being multiplied. And it can be numbers, variables, parentheses. These are all called factors. Okay? Example, 6. Well, 1 and 6 are its factors, as well as 2 and 3. What are the factors of 9xy? That would be 9 and x and y. What are the factors of the quantity x plus 2 times the quantity y minus 3? The factors are the things that are being multiplied, and there is multiplication hanging out right there between the two sets of parentheses. So that means my factors are x plus 2 and the factors y minus 3. The stuff inside the parentheses are terms. The factors are the stuff that have the parentheses that makes them into factors. Now, let's look at the bottom one. Okay, we have 3 parentheses, z minus 9 close parenthesis. What are the factors? The factors are 3 and z minus 9. Okay, what does it mean, or what's our special name for something when we simplify inside the parentheses? Take care of all exponents. In order from left to right, you multiply or divide. In order from left to right, you do addition and subtraction. Right? Well, what do we call this? Well, some of you will say, oh, it's please excuse my dear Aunt Sally. Well, what it really is called is the order of operations. And an example of the order of operations would be this lovely little problem here. Now, y'all, the really cute little TI calculators that we have, they have the little screen, they are scientific calculators. If you type this whole thing in exactly as it appears, including the parentheses, including the little 2 up there in the exponent spot, if you calculate and type it in exactly as it appears, it will do the order of operations for you. That's nice because we're not in middle school anymore. You guys get to use calculators. So it's real important that you know how to type things in to use the correct order of operations, because if you don't get the same answer as I do, and then you get it wrong. All right, so if you typed it incorrectly, you would get negative 18. Now, let's talk about translations. What does it mean? Okay, we need to translate from English into math. Okay, if I use the word sum, plus, add, more than, increased, together, these are all words that mean addition. I bet you could think of at least a couple more. How about total? When I'm talking about total, I'm talking about I added everything up. All right, I bet you could come up with a couple more. All right, now, what is the word, or what's the operation that means difference, minus, decreased, less than, and the words less than means we swap the order, okay, or takeaway. These are all words meaning subtraction, okay? Words, quotient, half, divided by. This symbol here that looks like the possibility of a fraction. What does that symbol right there mean? Well, these all mean division. Now, what do the words product, twice, double, triple, times, what do all those mean? That operation is multiplication. Now, if I square something, cube something, raise it to the power of something, or just say to the power of, and give you a number, I am talking exponents, right? And let's translate. The sum, okay, sum, that means I have addition, okay, of a number. I don't know what that number is, so I'm going to use a variable. And 10, okay? Well, that means I am going to be adding this unknown number and 10. So I would have unknown number plus 10. Let's translate. The product of 9 and x squared. Well, this says x squared. That would look like this. And 9. And product, this word here, means multiply. And we do not use the symbol x for multiply anymore. Now, we can put 9 and x, slide them up together, and I can get my multiplication. There I go. I have 9x squared. That means I am multiplying. Well, let's translate this. 9 less than g to the 4th power. Less than. Okay, well, this means I have some subtraction going on. Okay, and I have g to the 4th power. That would look like that. Now, my question is, does less than switch the order? Remember, if you go back and look at that slide, so 9 less than g to the 4th power. That means I'm taking 9 away from g to the 4th power. Right, now let's translate this one. 8 increased by 3 times a number. Well, what does the word increased mean? The word increased means addition. Okay, 3 times a number. Well, I don't know what that number is, so I'm going to use a variable. And I like using smiley faces. Now, 3 times that unknown number. Well, let's see, 3 times that unknown number. This means I am multiplying my unknown number by 3. Okay, so, and then I'm going to add 8 to it. So 8 plus 3 times x. Now, the nice thing about addition is it could have also been written this way, 3x plus 8. And those would be equal statements. And we're done. All right, hopefully you got all your notes filled in. If you have any questions, write them down, bring them to class, and I'll be happy to answer them because we're going to be spending some time translating.